Kind of an interesting combination, but weather codes and dresses.
I love
Who knew,
it.
right?
It's an interesting follow-up to what Jody Kurzman talked about last week with this 1880s dress that was found in a Maine antique gallery in 2013, and they didn't know how to solve this code that was on a crumpled up piece of paper in a hidden pocket in that dress. And it ties back to weather history, to the telegram era, when you had all of these different codes that were developed. So the telegraph changed communication, changed weather observations and weather forecasting in the 1800s. To keep it inexpensive, though, a sort of shorthand was developed with just an ordinary word like college or let's say acid being translated into a number or some sort of meteorological variable. So hundreds of code books were created in this time frame, and from that code in the dress, just based on 4 or 5 words, we got all of this weather information from Bismarck. That's how that ties back to here in North Dakota with the information from that day on that piece of paper in that dress translating to May 27th, 1888 and this weather map. So some interesting ways that back in the 1880s, you had weather codes that were used in telegrams, but even nowadays, you have these sort of codes that meteorologists use, especially when it ties into aviation and current observations, that you have to decode to get what it actually means. And one of the best examples is METARs. They're raw observation data from automated observing stations. For example, this was from January 14th during our Arctic blast, a METAR from the Bismarck airport. We'll break this down here piece by piece for this kind of just garbled mess of letters and numbers. So again, from Bismarck, 10:45 p.m. on January 15th, and then that had to be translated into our central time from Z time or UTC time, which is based in London, and that gets translated into central time. This part right here is for wind direction and speed. The direction is a degrees on a compass rose here, going from 0 is north all the way to 270 degrees is west, and all the way around the wheel there. So 290 degrees would be west-northwest wind, 15 knots, and that translates to 17 miles per hour. Visibility was 10 miles. We had sky conditions that were clear. And then this part here is the temperature and dew point in Celsius that had to be converted to Fahrenheit, and the M means minus, below 0 temperatures. Also on these METARs, you can tell what type of precipitation is falling, if it's light, moderate, or heavy, the type of sky condition or obstruction that we have, like fog, smoke, haze, and all of these different precipitation types are just 2-letter shorthand that is put into that METAR code that is then kind of translated onto weather apps and things of that nature that can be easily understood. But also with these METARs, you can have these remarks. Again, they're just a bunch of random seemingly numbers, but they can be translated into what the maximum temperature has been, what the precipitation has been over a past sort of time frame. So this was one of the first things we learned in my meteorology class, these METARs, kind of how to interpret this raw data. Let's take a METAR from this afternoon, where we had this part here, meaning January 24th, that time frame, a 210-degree wind, which means it was from the south-southwest at 5 miles per hour. This part here meant that we had a visibility of 10 miles, a clear sky, temperature and dew point in Celsius converted to Fahrenheit. And then this A part here, that's just the altimeter setting, which is important for aviation, kind of the height off of our Earth's surface. At the end here, the remark is telling us what the pressure is, the sea level pressure, and kind of the expanded temperature and dew point to the 10th place after the decimal. So METARs provide current weather observations, whereas another kind of coded weather format is TAFs, and they provide weather forecasts for specific airport locations. Again, these observing stations are pretty close to the runway, important for planes trying to land or take off in these weather conditions, and these can give forecasts out into the future by seemingly just random numbers and letters, but it all is this sort of code that is interpreted by pilots and by meteorologists in order to deliver some sort of forecast. Another kind of code that meteorologists use is station models. Let's zoom in here to North North Dakota. These are station models from today. And just by a quick glance here, we can see temperature, dew point, wind direction, and speed, kind of get a general idea as to how winds are flowing across the region and where there might be fronts or things of that nature. So on each one of these station plots, you get all of these different variables plotted with these numbers, these sort of symbols here. So let's dive into this a little bit more. It's something that's very useful from my map analysis class in college. Just based on station models, I could draw fronts and isobars, lines of equal pressure, find those low pressure and high pressure centers. Pretty interesting and powerful tools that is kind of a code for meteorologists. So the weather symbol right over here, that can indicate rain, snow, thunder, drizzle, fog, all of these different symbols here. The wind is plotted with this barb here, denoting how fast and from what direction the wind is blowing. Then you have this pressure trend here that indicates how the sea level pressure has changed over the past couple of hours. And the center circle, the amount that is filled in, indicates the amount that the sky is covered by clouds. Let's take station models from today. This was this morning. We had this symbol, meaning fog, with a temperature of 24 and a dew point of 23, just a southwest wind at 5 knots, so a pretty light wind. And this pressure, the numbers here translated to our pressure of 1,014.9 millibars. And then in the afternoon, we finally saw some clearing with a temperature of 33 and a dew point of 25, and the pressure rose there. So some interesting ways that meteorologists look at, especially current conditions and current observations, that is somewhat in a coded format, and it's interesting how we can decipher that and decode it.
Now you understand that, right? We look at this every day, all day long.
Oh, I've got it. I've got it.
It's great. You know what it equates to?
What?
Great weather ahead.
Oh,
That's all it
that's
means,
good
right?
news.
Yeah.
That's good news.
Yeah.
I'm very interested in the dress.
Yeah, the first 20 seconds was great for you, right?
Well,
Yeah.
that's what kind of tipped me off into explaining this, how that's changed from the 1880s with telegram codes and weather information passing along telegram lines to nowadays, we get those automated observing stations in the METAR format.
In the
So
METAR
critical.
format.
Yeah, it's great
right.
stuff. Yeah.
All right.
Thanks, Jacob.
You're welcome.